So, welcome to today's Tech Hour. I'm delighted that Milan Willett, if I've got the name right, will be joining us. He's come by chance. On the Tech Hacks, he said, could we please make the Tech Live distribution install a little bit quicker? And I said, well, actually, we're talking about that tonight, and why don't you come along? And I'm pleased to say that he's found it interesting enough to spare some time to have a look at it. So I'm a long-time member of the tech community. I'm retired. It gives me a chance to do my work in pure mathematics and to revisit the various ambitions and goals I have regarding tech. Before I retired, I worked at the Open University in the United Kingdom, and there I was the LaTeX officer responsible for the for the technical side of production of course materials. My job was to make sure everything appeared correctly. The editors had a job to make sure that everything was written correctly, and the course module team had a job to make sure that everything made sense from the point of view of teaching. So that was quite interesting. Perhaps can ask Nelson quickly to introduce himself.
Okay, I'm Nelson Beebe. I'm in the mathematics department at the University of Utah in Salt Lake City, where it's a beautiful spring day today. And I've been associated with tech really since the late 1970s when Don was working on it at Stanford. And I've had a long time involvement in tech-related software and in bibliography software. So that's enough for now, other than to note that I'm on a new laptop with higher resolution. I don't know whether this makes any difference at your end, whether you see a difference from the last time.
Oh, I think the picture's a bit better. I think the camera's better. And the voice sounds a little clearer to me. So maybe it works. William and Milan. William's on first.
I'm William Roos. I'm a retired programmer. I'm a LaTeX aficionado wannabe. And Nelson, I still can't quite read the titles on the books behind you.
Well, we won't wait for Nelson to reply to that. Milan, would you like to say a few words about yourself?
Okay. Can you hear me?
Yeah.
Yeah, okay. So actually, I'm a last year's master student at the University of Ghent. I'm doing a thesis in robotics. And of course, I have used LaTeX for a lot of things. And yeah, today I reinstalled TeX Live, and that's where my sudden entrance comes in, I guess.
Okay, I think if I can manage it, we'll do a bit of screen sharing.
Could I ask a question before we do that?
Go ahead.
Milan, did you happen to, first of all, which operating system did you install TeX Live from? And was it from the ISO image? And yeah. Did you happen to record how long it took?
I actually used the easy installer. So that's not the ISO image. It's the one that downloads every single package sequentially. So it's a small installer and then it downloads each package. So it's not the ISO image, but it took 3 hours and 20 minutes.
Okay, that's a long time.
But of course,
the reason this came up for me is that on my home workstation, which is a fairly modern Dell workstation with solid state disk, it took 45 minutes on Ubuntu 2004.
Yeah.
On my brand new laptop, which is the Hewlett Packard laptop with an NVMe 1 terabyte disk, I thought it would be much, much faster. But on Windows, it took still 30 minutes. Yeah. But that was from the ISO image in both cases, so there was no network delay. And it could be what you see is substantial network delay in getting files downloaded on the fly.
Well, I think not only because the network delay, but also because yeah, you cannot, with the ISO, you download everything first, and then you start actually decompressing and writing back to disk. But the thing is, in the way I see it, is that there's a long network delay in the sense that you need to set up a connection for each package, I think, if I'm not mistaken. And there is a lot of wasted time because there's also, while you're doing the decompression, you're not downloading other packages. So when you parallelize that, I think you can have a lot of gains in that regard. That's how I would do it, because I have also thought about the ISO way, because I think that's also a really practical approach. But I also think it has its downsides in the sense that it is harder to do like partial install, or for example, if you want to interrupt your download, most of the time that's not that easy, I think, because it's a file of like 7 gigabytes. If that's 3 hours or maybe 1 hour, for example, to download. But if you can't do anything else in the meanwhile, you can't just shut off your computer and look back at it. I think that's an issue with the ISO, or a downside with the ISO, I think. But nonetheless, I think it's the fastest install time for sure at the moment.
Well, I'm grateful for all these remarks, and it's really nice to hear the problems that other people have, getting a history from them. It's very important. What I'd like to do is explain what I'm up to, and then afterwards, perhaps even after discussing some other things, we can come back to this and see how it fits in with the problems we've got. Because I've sort of tried to rethink everything. So let me have a go at sharing a screen. Okay, so you should be seeing a page that says ISO versus TGZ versus Git. So you're getting that? Yeah. And I spoke about this a couple of weeks ago, I think. And I've got some news at the top, but from what, but it's worthwhile recapping this so that Milan gets a chance to see it, and also because some of the stuff's quite relevant. So what I've done is I've eliminated all sources of slowness as best as I can from the environment. So I'm using a RAM disk, which is as quick as you'll ever get. And I'm using my brand new computer, which has got 12 cores and 3.4 point something gigahertz. It replaces a machine that was 11 years old. So everything goes very quickly. So the TeX Live 2022 ISO is about 4.3 gigabytes. And it takes 10 minutes using a RAM disk as the source of the ISO and the output. No, 9 minutes to do a complete install. So using the installation script with everything preloaded, you'll never get below 9 minutes unless you're an extreme overclocker or have got more than £1,000 to spend on your computer. Now, there's something that you can do with a RAM disk, which is that you can copy files very quickly. And I timed how long it takes to copy one whole complete installation into another directory. And that took 3 seconds. So you'll never be able to do an installation less than 3 seconds. So the next thing I did was I took a complete install. What did I do? I extracted a complete install. I zipped up a complete install, and then extracted it. And that took 30 seconds approximately. And I put the whole thing into Git and then extracted it. And that took 16 seconds, which surprised me that it was quicker than a TGZ, but I suspect that the compression was quick, decompression I expect was quicker. And all these things come out at about the same sizes. I'm going to have to confess that I haven't scripted everything, and so these are potentially these results are potentially wrong, but they're certainly giving the right figure of things. So it's putting some bounds on what's possible, and it's saying that if everything's set up right, you've got the disk overhead, which you can't avoid. But if you have a fast processor, then you ought to be able to do an installation in a matter of a minute or two, plus the disk overhead, whatever that is. So I'm now going to go on to the next stuff, which is these two links here. So I created two scripts. Alice, Carol, and Bob are regular appearances, regular characters in cryptography, and they're always sending messages to each other. And here, what we're going to do is Alice is going to send a message to Carol via Bob. So Bob is a server, and like any good servant, says nothing and does nothing until the bell rings and he's asked to do something. So Alice will say to Bob, please accept my message. I'm going to push it to you. And Carol will say to Bob, please fetch the message you got from Alice. I want to get it from you. So I'm going to explain how we can do that using Git. And the second stage, I'm going to use A, B, and C, but it's apple, cherry, and banana this time. So we're going to send a tree of files via banana/Bob. And that is more realistic in terms of what we're doing. So the first one is more about the Git stuff. And the second thing is supercharging it so we can deal with files. So I've written a script here, and it's got some text in it. But I'm going to, let me make that a bit bigger because I think it deserves it. So the first thing I'm going to do is I'm going to create repositories for Alice, Bob, and Carol. And we're going to make them bare repositories because we're not going to be doing any version control. I know Git is a version control system, but it's built upon what's called a content addressable store, which is a sort of file system. Worth saying, Linus Torvalds said he only created 2 pieces of software, and he named both of them after himself, one of which is Linux and the other of which is Git. He's become more settled as a person, I think, as he's got a bit older. There is less flaming. So these 3 directories, these 3 repositories are identical. I'm using the diff command to show you that they're identical. And what's going to happen is that a change is going to take place in the Alice repository, which will propagate to the Bob repository, and then the same change to the repository will propagate to Alice. So as it happens in this case, not only do the files transmit, but the repositories become identical. And I think that's quite interesting, and it gives a bit more security to this confidence to the system if we can manage this. So here's how to add a blob. Now, a blob is what we would call a file. But as far as Git's concerned, it's opaque. Git doesn't look into it and say this is what it is. It's just a sequence of bytes. So the way one way to create a blob is to echo a message. Hi, Carol, this is Alice. And you pipe it through the Git command, and you say what the Git directory is, which is Alice's repository, and you ask it to execute the right object command and the hash object. And when you do that, you're going to get the input from standard in, and the -w means don't only compute the hash, but put the object in the store. So this is a way of putting a blob into a Git repository and knowing where you've put it. So it's a bit like going to the theatre. Do you remember going to the theatre? It's a long time ago. And handing your coat in and getting a ticket back. And as long as you keep hold of the ticket, you can get the coat back. But what is unusual is that the ticket you get from the repository is computed from the code. So you always get the same code back, or rather a copy of the same code, because the copies are indistinguishable. That's one of the marvelous things about computers. So when we execute this command, Git will give us a hash back, will give us a hash, and here's the hash we get. We always get this hash for this message. If it's a different message, we get a different hash, unless you've got over $1 million to spend to create a hash collision, and then even that isn't enough. So what we're going to do, so this hash is very good for the computer, but it's not human readable. So we'll give it a human readable name by putting a tag on it. So we give the object we stored, which we access via the hash, the tag a message1. So this is Alice's first message. So we haven't touched the other two repositories. So we'll diff the Alice and the Bob repository. And in a moment, I'll do some more screen sharing and you can see what happens. So the next thing we do, this will show us that there has been a change in Alice, in the Alice repository. So the next thing we do is we push the message to Bob. So the git dir is where we're executing the command. Where is the repository? So the git dir says, here's the repository we're going to use. So we're going to use the Alice repository, and we're going to push to the Bob repository, and we have to say what it is we're pushing. And we could have specified a hash. That would work. That would tell Git what to push. But no, we'll ask it to, actually it won't work because it won't push hashes. It doesn't allow you to push hashes as far as I recall, but we can push tags. So we'll ask it to push this tag. And after we've done that, the Alice and Bob repositories come out to be identical. And the repositories for Bob and Carol are different. So we're nearly there. Now Carol fetches the message from Bob. So now we use Carol's git dir, we fetch from Bob, and this says fetch the message, fetch a message1 from Bob and tag it in my repository, the Carol repository, as a message1. There may be a way of avoiding that repetition by using the command line in a more intelligent way, but I only did this today. So this is the best I can come up with, and it is explicit. And to check our work, we can diff the Bob and Carol repositories to see if they're the same. And with my version of Git, they're not the same because it's lacking a feature that more recent versions of Git have. But when I update my Git, they will be the same. And then finally, remember I started to say, here it is, where is it? This is how we got a blob into Alice's repository. So we use the hash object to put the object into Alice's repository. We then took Alice's repository, pushed the tag to Bob's repository, and then Carol fetched it from Bob. So this message that Alice put in her repository should now be in Carol's repository. And this is the command that gets it out again. To avoid switching screen sharing too much, I'll show you the other script at the same time. This time, we're going to create a whole tree. So we're going to use apple, banana, and cherry. So we've got different named repositories. And we're going to use a different command, git add, to store some files. So this is saying the git dir, saying which Git repository you're going to use. And the work tree says, when I pick up files to put into the Git repository, this is where to pick them up from. So I'm just setting up 2 pointers to say, this is where stuff is going from, and this is where it's going to be stored. And we're going to add all the files in this path relative to the work tree. So we're getting all the files in knuth lib. And this first part here is part of the path to the files. And this is like the current directory. And then there's a command called write tree, which is a bit like the hash command that I used, that will give me a hash that contains the tree we just put in. And then we tag it as before, and we can check that the tag is there, and we can push it, and Apple can push it, and Cherry can fetch it. And finally, git cat file will show us what the file is. So I'm going to stop the share for a moment so that you can ask questions. And then we'll see it run at the command line. And we can perhaps explore it a bit more if we want to. So I'm going to stop the share. Sorry, I feel as though I'm back at university teaching a class, and I was renowned for my sense of humor. So how have I done? Is it come through what's going on? So the main thing to remember, if you know nothing about Git, think of Git as a distributed file system. So it's a bit like a shared network drive. But the other thing about it is that every object is stored according to what its content is. So you don't talk about the file at the end of such and such a path. You talk about the file that has such and such a hash. As far as Git's concerned, 2 files are identical if they have the same hash. And the hash is what's called a secure hash, which means it's as secure as we know how to make it, and nobody's broken it yet. We can sort of argue a bit about details here.
Jonathan, is it the case that just a minute, that anywhere you had a file path, you could simply put a URL and it would go out on the web and fetch it? Oh,
absolutely. I didn't mention that. Yeah, if you have a Git repository and it's exposed to a Git server, so you have a web server that serves web pages, you can have a Git server that serves Git repositories, and you can use HTTP as the transport mechanism, or you can use the file system as the transport mechanism, and it doesn't make any difference. It's the same to Git.
Okay, and so one of those single Git commands then could have pulled the entire TeX tree from another system onto your system.
Yes. And let me tell you something amazing, something wonderful, which is the first time you pull that entire tree, it might take half an hour. The second time you pull that tree, it will say, oh, I've already got that tree. I don't have to do anything. So it'll come back immediately. And if you change 3 files, all it has to do is pull the 3 files that have changed together with the hashes that have changed all the way up. So essentially, that's just the 3 files that have changed. And if you pull 1,000 files and you've got 500 all of them already, you will only fetch the 500 you need. And it knows whether you've got the files or not by comparing the hashes. And the hashes are very small. Well, they're long to the human eye, but they're quite small compared to the size of a file.
So,
Milan.
yeah. So in my point of view, you are trying to use this as a mechanism to download packages of TeX, or am I mistaken?
No, but that's the application I have in mind.
Okay.
So each package should be an object in a Git repository.
Yeah.
And each of these packages will also have a tag. And the CTAN archives can swap packages between each other by doing pushes and pulls. Git is a peer-to-peer system. There's no central repository that is privileged inherently. It may be that we'll treat some repository as special, but there's nothing in the repository itself that says I'm special. So there was a time when the Git system, when the Linux kernel server was compromised, and they couldn't use the Git server there for a period. So they just used the mirror that they had on GitHub, and it was exactly the same. So to shuffle all these things around, you just have to do pushes and fetches. If you're an author, if you're an originator, then you push, and if you're a consumer, then you pull. And that's pretty much how it works. What was the question again? You asked me.
Well,
how does this
a
fit
file
in with
path could be a URL.
Yeah, yeah, that's right. You could, instead of using Bob as the name of the repository, you can use HTTP etc. as the name of the repository. And having said that, Git allows you to configure names of repositories. They're called remotes. So you can actually name your remote repository Bob, and it will look up in the repository, say, oh, Bob, he means by that Bob on GitHub. So that's a useful piece of configuration. You'll find that because so many smart programmers doing so many clever things have been using Git and developing Git, that it has bells and whistles for many things that you want to do. So is there another question? I'd love another question or a comment.
Well, another one is that the packages in CTAN and TeX are little bundles of zip or tar or something like that, and they're pulled across and then unpacked into various directories. In the context of Git, the end user of current TeX can decide which packages that user wants and would pull them over by a package name. But with Git, it seems to me we're now looking, are we looking at directories within the tree? Because the issue I had was that a single directory may in fact contain files that are contributed by multiple packages. Okay.
This is getting into the sort of architecture of TeX Live, and you've got two conflicting demands. The one is the package authors want to be able to submit a tree, and then the other thing is you want the tree to be organized in a particular way that's convenient to the software. So you want all the fonts in one place, and there is an approach we can take to that, which is Well, the easiest, from one point of view, the easiest approach is to have a granularity so that we don't need a single tree, but the problem is that these packages sort of mix and mingle together.
Mhm.
And one way to do it is to say, okay, a package has got a documentation part and a fonts part and a macros part and whatever, and we'll treat each of those parts separately. Another thing to do is to say, well, a package should say how it should unpack itself into the tech tree, and we'll just allow every package to go where it wants to, which is actually, I think, what happens at present, is that every package goes where it wants to, and some check is made at some point of some sort, so that one package doesn't clobber another package. I'm not tackling that problem at this time. My problem at this time is to get the files moving around from repository to repository quickly and efficiently. And the basic idea is that anything that you want to have independently retrievable will have a tag. Now, a tag is very cheap because it consists of the name of the tag and the secure hash associated with the tag. So if you have the TeX live tree, and that's one tag, every folder in that tree can also be given a tag, and the cost is one line of text for each additional tag, approximately. So tags are really cheap with TeX, with Git, and if through the tags you've already retrieved, you've got 90% of the files, and you ask for the rest, you only have to retrieve the files that are missing. That's really the benefit. And that means that if you installed TeX Live last year and you still got the repository, your next year's download is actually quite small because most of the stuff has not changed.
Okay.
I think, yeah.
Sorry. So
Yeah, go on.
if I am right, you want to the others to actually push some objects to a general repository. Is that correct?
Well, push and pull or push and fetch are not that much different.
Yeah.
So on GitHub, if you want to make a change to somebody else's repository, you don't do a push, you make a pull request.
Yeah, I know.
So push and pull are basically the same operation. The only difference is in the initiator.
Yeah.
And whether the author of a package advertises the fact that this new version is available, or whether the owner of the hub repository says you have the right to push your stuff when you want to, it's just a question of it's the difference between
Yeah, I think it is indeed the initiator, but also a definition of who has the highest privileges.
yeah,
Because from what I see, you can also do in GitHub like subtrees or actually repositories in repositories.
say that again, Melon. I didn't quite catch it.
You can have repositories inside repositories. So,
okay, you can have sub-projects.
well, it's actually just a reference to another project. For example, in the case of TeX Live, I'm not sure if that's an option, but one could argue that, for example, the fonts directory just has a reference to all the repos that have the fonts themselves, so packages in itself. But it all depends on how you want to push and pull and what you want to do. For example, if is it a zip archive, is it the source code, there are a lot of questions there, I think, and it really depends on what you want.
I'm going to complicate things in a way that might simplify things,
Yes.
which is when we draw lines, we're drawing lines. And the British are famous for drawing lines on a map that don't mean anything, but they do mean a lot because they divide one country from another. Now, I'm going to draw a line between data and metadata. And for me, the contents of files are data and everything else is metadata. And the same files organized in a different way is a difference in metadata. And approximately speaking, the data is big and the metadata is small. And I'm thinking of the tags as a way of efficiently communicating the data. So it may be that to install stuff, you need certain data available on your computer, and you want one or more tags that will give you that data. And whether or not you've got the appropriate metadata is another matter. But that appropriate metadata is another matter. So I'm thinking of this largely as an efficient way of moving blobs, but it does have other features that a TeX Live like. And if we're talking about the performance of the download and the performance of unpacking, the metadata isn't that important. It's the way the blobs are handled that is perhaps more important. I think if I show you the demos, things will become clear again. So I'm going to return to screen sharing. Where are we? Share screen. Here we go. Okay, so I'm going to run the script that I just showed you. So first of all, there's nothing here. There's really nothing here. Now I'm going to run the script I showed you. The first script that I showed you, the Alice Bob Carroll script. Didn't take long, did it? But now we get to see the outputs. So here we're creating the repositories. And here we're looking at the differences, and because we don't get any output, there aren't any. And here we're creating the hash, and the hash goes into the standard output. So if we do this command at the command line, we'll get this output. And here I store the hash. And here I create the tag, nothing happens. Now let's see what's changed. We diff the repository, the Alice and Bob repository, and the DA is simply the way in which, the DA is simply the way in which Alice stores objects. Underneath the DA is the rest of the URL. Do you see here the hash is DA? Okay, so underneath there's this part, and that's got the object in it. And the A is the A here for the tags. So it's just a folder, and because this folder in the file system exists only in Alice, it just says this folder is only in Alice, not in Bob. So now we push, and here's the push. And the repositories now are identical. We don't get any output. And for Bob and Carol, they're different, as they must be. And then we do the fetch, and we get this error here because this is a recent. Stopping this error here is a recent feature in Git that I don't have in my old-fashioned 18.04 Ubuntu. I discovered that today. So that will go once I'm able to put the new option in that makes it go away. And we get this noise here, but here is the payoff. Carol gets the message from Alice. So this is how we get Carol. This is how Carol will read the message from Alice without using a file system. It's just saying, here's a tag, cat the blob that is at that tag. That's what we're saying. And that's the message. So that's quite a complicated way just to send a message. But when you think about it, I'm talking to you and I'm sending you a message, and that's very, very complicated, and it works reliably most of the time. And when I use chat, that's also a complicated way of sending a message. So in terms of what computers do under the hood, this is quite normal. It's just a bit of system programming, if you like. So having done that, we've got another script here whose name is, you can probably guess what it is. It's apple, banana, cherry. And that didn't take long. And let's get to the punchline. We cat file, and there's a funny variant here. We say, here's the tag, right? Fonts Knuth lib is a tag, which stands for the hash of a tree. And the colon means, once you get that tree, tell me what is at this path. And we get a bit of metafont. Those people that know metafont will recognize this. What's the word? Doesn't have much white space in it. Distance stuff that Knuth does for his metafont. And at the beginning of this script, we used, you actually saw this, we added this stuff using the worktree command, and then we used git write tree, and we got this magic number here that is the secure hash for the tree that we just checked in. So that secure hash is not a blob, it represents 50 or 100 files together with some metadata that organizes the files. And the metadata that organizes the files allows us to use something like a path in order to retrieve just one of the files. So it's just a file system. Can I stop the share and we can talk a bit more? And then I'm afraid I've occupied practically the whole time.
So
No,
one
I
issue,
think-
John, one issue is that some sites like mine essentially want to have a complete TeX tree that's kept reasonably up to date. I generally update 2 or 3 times a week for all of our users, and then it's shared among hundreds of machines. But other people on mailing lists say, I have a relatively small machine. I'm only interested in this little portion of the fonts and this set of packages. And so we realistically have a situation for many people where their tree is distinct from everyone else's. And so the concept of updating from a master tree via Git is something that I'm unclear as to whether that's even feasible. I can see how they can do it with TeX because it's been doing that for years, pulling down just the packages they've selected.
It will work. The way to see that it works is to realize that metadata is cheap. So if you say my TeX Live distribution has got these packages, then you can say to the central repository, give me the latest version of everything that I'm interested in. And then from the metadata, you can actually, just from the metadata, you can compute what the secure hash should be for the tree you will form. Because the secure hash is computed bottom up from the secure hashes of the blobs, and the metadata is rooted on that. So that will give you a secure hash that describes your particular tree at that particular moment. Now, this isn't what you asked for, but it's something what I want, which is somebody who's got a problem, they can publish that secure hash together with their additional metadata, and anybody else can build exactly the same tree. So there's a magic function that says, here are all the packages I've got, and here are all the revisions that I'm using. And that determines, of course it does, that determines the tree that you get. It also determines the secure hash of the tree. So that more or less answers your question. I focused today, I was doing all this morning, on how can I officially get this stuff into Git and move it around from server to server. So you can think of this as an alternative way in which CTAN could work. Every server, you just say CSAN, it's got all these hashes, these are their values, you can get any hash from any server. Doesn't matter where you get your kilo of sugar from, it's a kilo of sugar, and they're all the same. So that's the problem I've focused on solving. And to be honest, I'm working on habit in answering your other question, which is a good question. It has to be sorted out. I'm going to come back and answer your question with a different question, which is, what should we call everything? What tag names should we be using? And I don't know the answer to that. A lot of it comes down to choosing names that are convenient in terms of the facilities that Git provides.
Yeah, I'm not sure about naming either, but certainly since I control the North American master mirror for CTAN and TeX Live, we could set up a Git parallel archive that would allow Git pulls from what would effectively be the CTAN or TeX Live trees. And I suspect Carl might be able to pull that off in the master site in Paris. That's a site that's hosted commercially, so it does cost money. I can provide the space here for free for North America, but we would undoubtedly be able to get some contributing sites who are willing to set up a parallel Git repository as an experiment to see how all of this might work. So I think this is a very interesting development you proposed.
Yeah, I feel that the next thing to do now is to create some medium-sized repositories that have got a lot of data in them, a lot of blobs in them. And then it's a question of managing the metadata. And you can do that. It's a bit like wire transfer of money. You don't have to move gold around anymore. So when you're rearranging files with metadata, You don't have to move the files around. They always remain where they are because it's a content addressable store. You're just manipulating the objects. So that's promising. And the next step for me, I think, is to build some sort of Git repository with a lot of stuff in it, by which I mean perhaps up to 1 gigabyte, perhaps half a gigabyte is enough to get going with, that you can unpack in multiple ways. And at that point, you might be ready to be using it, so to speak, for real, for life. I think there is a bit of a problem with the generated files that are the LSR file index. I have my own views about how that should be managed. But if we just say, this is an alternative transport mechanism for Git packages, for TeX packages, or CTAN packages, that would give sufficient value to make it, potential value to make it worth being evaluated. I think that's right. Let me welcome Abbas, who kindly came last week and might have had an error with the time zones because it's nearly 7:30 where I am. We'll stop at or soon after 7:30, but I can spare about 20 minutes or 15 minutes after 7:30 before my next event. So I can catch up with you then, Abbas, if you'd like.
Oh, sure. Yeah, I'll be doing some things this afternoon, so I can reconvene whenever.
Okay.
I was just chiming in just to say hello and listen in.
Okay, well, we are being recorded, so you can pick up what you've missed, and I'll catch up with you after we turn the recording off. It's now nearly 7:30. I'm delighted at the attention you've given me and the patience you've shown me and the interest you've shown. Let me just say personally that yesterday when I announced this meeting, I didn't know exactly what I would do, but I knew that I would spend some time on Thursday working on this. And I'm retired, so I don't have a manager telling me what to do. And what you've seen today is the work I did today, effectively. I've been doing a lot of background work for a long time, but the two scripts I showed you are fresh today. And I'm really pleased with the amount of progress I've made. And I feel as though I'm be ready in a couple of weeks' time to tell you about the next step. At that point, I will be quiet and let anybody that wants to make any closing remarks, and then I can stop the recording. Thank you all for coming. And it's really nice to be able to share these things with somebody who's interested. So thank you all. Do you want me to do the Bugs Bunny? That's all, folks. Well, anybody, any closing remarks from anybody else? Was it fun? Yeah.
Jonathan, you and I could communicate by email. We could perhaps collaborate over the next few days or weeks on setting up a pilot project, say between Salt Lake City and Milton Keynes. Just with the two of us getting data moving back and forth, and then we can worry about how to replicate this.
You've suddenly got a CTAN node, which is something I don't have. So getting it into the CTAN ecostructure is something that you're really much more capable of doing than I am. Whereas I'm sort of a bit better placed, if you like, at getting it into the GitHub infrastructure.
Mm-hmm.
And the so to speak, the automated picking up of updates from CTAN will be needed at some point, particularly if there's a a period of parallel operation, which could be quite extensive in time. So that offer is very much appreciated, and let's have some email conversation to take it forward afterwards. I'd like to thank Milan for coming along, and we both share experience of Python, and at the moment I'm not using any Python, but when I have to do scripting that goes beyond simple bash stuff, I will be wanting to do Python. And I think Python's quite a good language for making sure that what you're doing is well defined.
It's also quite easy in the syntax. That's also.
Oh, there's something I wanted
good.
to say about multi-core, which is that when Git packs a repository into a pack file, it will use all the cores it's got.
Yeah,
So it can go like crazy if you've got enough of them.
Yeah, that's exactly one of the key benefits of your proposal, I think. But yeah, I think the biggest thing you should keep in mind is how will it compare to the existing C10 infrastructure, and what are the pros and cons between them. So if I understand correctly, most of the packages are managed on C10 at the moment.
I think what we want is no changes, except everything's quicker, everything's easier, and there's fewer bugs. But whenever the user experience is satisfactory or better, you should not change it. I'm reminded of something Intel used to do. They used to do TeX and TOX when they did their processors. So I can't remember which is which, but one of them is using a new architecture, a new CPU architecture, and the other is refining the manufacturing process. And they would do either a tick or a tock. They would never do both at once. So this change should not be combined with any other changes.
Yeah.
Try and keep everything else the same, which is in a sense what you've already told me, and that's just why I'm reminded of it. So thank you very much for that.
But so in essence, the packages, will they be stored only on the C10 or also on a GitHub or Git repository as well?
Well, I think a parallel thing would be where C10 has its own Git repositories. And the great thing about Git repositories is that you can set them up so that they are identical. But keeping them identical is much easier for Git than it is for ordinary file systems using rsync.
True.
I think that's one of the important things, is that you can ensure that your two Git repositories are identical. And it works a lot easier because rsync is built upon name addressable stores, whereas Git is built upon content addressable stores, and it's built from the bottom up to be what's the word? Distributed.
Yeah.
And it's quite heavily hammered by people that know how to fix things and how to break things. I mean, by which I mean the Linux kernel developers. So it's pretty reliable.
Yeah, exactly. I think it will be interesting to see how it will play out and how it will come together in essence.
Yeah, I think one of the next steps is to say, look, we're going to build a toy example.
Yeah.
That people can actually use. And I suppose I'll have to start using it at some point.
Yeah, just because when you compare it, for example, to package managers for existing languages such as Python or JavaScript or any others, mostly they use actually just a file that has names and hashes for each package, and yeah, then can fetch them through the name or hash or through a URL. So that's what is used, for example, in Python packages. And it's quite similar to what you're going to do, I think, but just in another format.
But I think there are some differences, and there was a packaging conference last year in November, I think, and I gave a talk about that where I introduced the concept of portable TeX documents, and the idea is that every TeX document has a tree that is required to process the document, and that you ought to be able to store the metadata for the tree in such a way that you can rapidly retrieve the actual tree, the blobs that you need, and reprocess the document so that a portable TeX document will run identically on all machines. So that's one of the factors that has been influencing my thinking. But on what we're doing today, I've been largely focused on the efficient transport of files. And that is using the Git infrastructure wherever possible. And what's the word? Don't repeat the same calculation twice. In other words, if you retrieve the file once, keep it and don't ask for it again.
Yeah.
I'm going to stop because I've got another meeting in 20 minutes and I will need to rest my eyes a little bit. So thank you all for coming, and I'm really heartened by what's happened today. So I'm very pleased. Thank you all very much.
Okay, till next week.
Yeah, till next week.